Thanks for tuning in at Brackeys.
Hello everyone and welcome to video number 17 in the How to Make a 2D Platformer course. In today's video we're gonna have a look at making our shooting mechanic look a lot more awesome. So we're gonna really gonna tie it together with graphics. That means that we're gonna make our shooting trail, our bullet trail, actually stop at the point of impact. And we're also going to add some hit particles, so that's going to make it look a lot better. So as always, if you have any questions, go to forum.brackeys.com. You can also just open up a discussion about any subject, whatever. And yeah, let's just dig right into it. So Unity is just where we left it last time. I haven't made any changes except one. Since the last video, I've switched from Mono Develop to actually using Visual Studio, and it's awesome. So I've always been a great fan of Visual Studio. I think it's one of the best things to have ever come out of Microsoft. And if you're on a Microsoft computer, on a Windows computer, please go ahead and use it. It's really, really awesome. Don't get me wrong, Mono Develop will do just fine for most of the work that you're going to be doing, but Visual Studio is a much more complete and feature-rich development environment, so I really recommend it. And now it's beautifully integrated with Unity. And so if you want me to do kind of a video where I show how to set up Visual Studio tools and all that, please leave it in a comment and I'll definitely think about it. So that I just wanted to mention that that's what I'm using now. Awesome. So let's get started with today's subject. So first off, let's select the player and dig under him and go under arm and select the pistol, and you will see that on the player here we have a weapon script. So if we double click this, it will open up in Visual Studio. You can of course follow along in Mono Develop. And I'm just going to double click it again to make it actually open up the script and not only the solution. Zoom in a bit here so you can see what's going on. And you can see that we have a shoot method and an effect method. And we want to make a few changes to both of these. But first off, let me explain what we're doing. Because right now when we hit play, it will spawn in a... whoops. What's going on here? Oh yeah, I made a change when I was testing some things out here. I'll just quickly revert that change. So it was just the move trail component. I just deleted that for some testing purposes. We're gonna delete it again in a sec. But where we left off last, we'll have this move trail that spawns in a prefab that then very, very quickly travels through our scene. And it looks fine. It does, but it doesn't stop when we hit an enemy or a platform or something. And we can go through and add some kind of distance check or collision to this trail to make it stop on its own. But I think that would just be not very intuitive and actually require more work than necessary. So instead we're going to change the way that we do these bullet trails a little bit. And that is from moving the trail to simply changing the positions, the start and end position, and then just having it display for a single frame. And that way the eye will not notice that it's not moving, and it will look like an actual bullet trail. And this is how so many two-dimensional bullet trails are done in a lot of very beautiful games. So it's not that this is in any way a bad solution, it's just much easier. So I think we're going to go with that one. Cool. So the first thing that we'll want to do is of course delete the move trail script, and then let's drag it into the scene and make a few changes to this. So first off, we want to disable cast shadows and receive shadows. I don't know where they were enabled in the first place. And you can, of course, go under the material here and change around with this. I'm just going to leave it for now. And then we are going to go under parameters and bump up the transparency, or we're going to remove the transparency from the start color. So that's, again, visible. And I'm going to make it a cool orange color here. You can copy my RGB values if you would like. And we're going to do the same with the end color. And then most importantly, we're going to check it to use world space. And that means it will jump down here because now it's no longer affected by its position in 3D space, but only sticks to the positions given here. And that makes it very easy for us to tell it to kind of give it a start and end point through code, because we don't have to kind of orient ourselves in the hierarchy. We can just give it a position and we know that's a global one. And then also I'm going to bump up the start width and end width to something like 0.07, just so it's going to be a bit clearer to see. Now we can reset the position, not that it matters a lot, and then we can hit apply on the prefab and delete it from our scene. And of course, make sure that it's still assigned on the weapon prefab to spawn. Cool, then let's hit back into our script. And what we're going to be doing here is, first off, we want to store a reference to the trail that we just spawned. So we're going to make this a type transform, and we're going to call the trail and equal it to the newly instantiated prefab. And we're going to cast it to a type transform. Then on that trail, we can grab the line renderer. So we're going to go line renderer and call it LR. And we're going to equal it to trail.getComponent and then line renderer. There. And then just to make sure that the line renderer is actually assigned, we're going to say if LR is not equal to null, just so our code will work in all instances. And then in here, we'll say, we'll set some positions. But in order for us to do that, we'll have to have both our starting position and our ending position. And currently we only have our firepoint.position and not whatever we've hit. And if we don't hit something, we just want to make a point very far out in space, but in the general direction that we are shooting, so that it won't, the camera cannot see that the trail is ending, and so that it follows the trajectory of the bullet. So in order for us to do that, I think we're going to restructure a bit here. So first off, we'll move the effect handling below our actually collision code. I just think that makes a bit more sense. Then also we're going to pass in an argument here, and it's going to be of type vector3, and it's going to be the hit position. And then here we want to pass in that hit position when we're calling the method. And we first off want to make a hit position variable, but we don't want to assign it just yet. Instead, initialize it. Just want to declare it. And then down here, what we want to do is we want to check if we've hit something. So if hit.collider is equal to null, if we have not hit anything, then we want to, actually let's just not use these braces. Then we want to set hit pos equal to, and then a point far off in the distance, but continue in the same direction. And we can do this just like we did with the draw line up here, by simply subtracting two vectors, we'll get a direction, and by then multiplying it, we'll make it go farther off into space. And I'm not going to multiply with 100, I'm just going to multiply with something like 30 maybe. I think that's going to be plenty. So if we don't hit anything, just continue into space. Else, if we do hit anything, then we're going to do hit pos equals hit dot point. So remember, we collect some information about our raycast that's stored in the hit variable, and hit dot point will return a vector3 position of the point that the raycast had an impact. And then we'll just feed in the hit pos, feed the hit pos into the effect method, which will be called here. And now we can use it down here to set some positions. So in order to do this, we'll do lr.setPosition. And first off, you want to give it an index, which is going to be the number let me find it here, bullet trail, the number in the array of positions, so it's going to be the element number that we want to set. So first off, we want to set the starting position, which is going to be element 0, so we'll type in 0. And then the vector 3, which is going to be firepoint dot position. This way it will look like it's appearing from our gun. Then we'll do lr.setPosition and then pass in 1 for our ending point. And here we simply want to type hit pause and close that off. So now when we hit save, go back into Unity, hopefully we have no errors. Indeed, we don't. That's amazing. Always love when that happens. Not that it's actually pretty rare. So let's hit play here and let's cross our fingers. And indeed it's working. You will notice that it doesn't disappear at the moment, but you can see that it starts and stops at the correct position. And it looks like it's failing here with the platforms, but that's actually because they are using simple box colliders, which was something that I actually wanted to kind of straighten out. Let's see if we have the time. Yeah, this is not my first take. It doesn't look like it. So we're gonna continue on. Maybe we'll do it in another video. Maybe we'll have time. Let's see. I just want to, we'll do it very quickly. Change my mind again. So delete the box colliders, instead add, if we go under physics 2D, some polygon colliders, and we'll just make it fit on its own for now, I think. And then later we can maybe go in and do it ourselves. Actually, I'm not too satisfied with this. We should really go in and edit this collider manually to get it looking nicely. Let's see if we play this. It's better, but it's not really ideal. I think it will have to do for now. So we'll just leave that and then come back, don't worry. This is not their final stage. Cool. So now that that's working, all we need to do, go back into Visual Studio. All we need to do is to remove this prefab after a short while. And we're doing the same down here with the muzzle flash. So we simply put in destroy and then not clone.gameObject but trail.gameObject after 0.02 seconds. Now let's hit play, and we should see this working as intended, and indeed it does. But it does seem to destroy rather quickly some frames, so we'll maybe just bump this up to 0.04. Let's see. Yeah, I like that better. Cool, so you can see that working now. And then we can continue on to some hit particles. Yeah, that went pretty quickly. Awesome. So in order to spawn some hit particles, we need, of course, a position, but we also need a rotation because they need to be facing the opposite direction of our impact. So if we follow along a line, let's say we hit our enemy here, so we follow along this path, then we want them to be facing towards our player. And there are so many ways to do this, but a very easy way is by using the hit normal. And that won't always make it face our player. And I'll show you just what it will do, but it will make it look pretty cool. And some like this and do it intentionally, and others just do it because they're lazy. I actually like this effect, but I'll show you what I'm talking about in a second. Let's just try and implementing this. So first off, I want to explain that whenever we are casting out a ray, let's say that our player is up here and he's casting a ray down towards our platform. What the hit.normal will return is the rotation in Euler angles that or it's actually, I should say, it's actually a vector 3 with a direction from where the normal here is facing. And the normal will be, when you see this collision phase here, will be pointing exactly upwards from this place. So if we hit over here, it will point to the left. If we hit down here, it will point in this direction. So it will always be perpendicular to whatever line you have going through. And that's kind of what a normal is. It's perpendicular to a tangent. Cool. So now that we know that, we can use normals to our advantage. And let's do that now. Cool. So in order to implement this, what we are going to do is we're going to pass in a normal just like we did with the position. So in here, we're going to pass in the normal. So we're going to do comma, vector 3. Oh, I'm sorry. We're going to simply do hit dot normal, I think. Just put it in there. And because we want to check whether or not we've hit something in order to instantiate these. So I think what we'll do is set the normal equal to something crazy if we don't hit anything. Or we could do that with the hit pause. Yeah, we'll do that with the hit pause. Now, no, that's not going to work. Okay, I've decided now. What we're going to do here is we're going to make a vector 3 called hit normal. And we're going to default it to nothing. And then down here, we want to put in the hit normal. And what we can then do is in here, now we're actually going to need the braces. In there, if our collider is equal to 0, we're going to set the hit normal equal to a new vector 3. And we're going to equal it to 9999, 9999, 9999. There we go. And this way we'll be able to check if it's equal to this, and if it is, we'll know that we shouldn't be using it. We could also do this by a separate argument with a bool or with a null value type. There are plenty of use cases, but for now we're going to do it like this, and then else we're going to say hit normal equals hit dot normal. Then down here, what we can do is we can say if hit normal, oops, need to declare it up here, so comma, vector 3, hit normal, and then down here we can say if hit normal is equal to vector 3, 9999, 9999, 999. There we go. This is not working. Is equal to new vector 3. There we go. And then we open up this. And what we say in here is now that we know we've hit something because our hit normal isn't going crazy, what we can do is we can simply say instantiate. And then we need a prefab to instantiate. Instantiate, yeah, cool. And we can declare that up here. So we're going to make a public transform. And we're going to call this hit prefab. Simple as that. And then down here, we'll instantiate hit prefab. As the position, we'll take in the hit position. And as the rotation, we'll do quaternion dot from to rotation. And then we'll pass in and we'll just try with, I think this is going to be vector 3 dot right, I believe. If it is turned like 90 degrees to the left or something, then just try and mess around with this. Try up instead or left. This is how you can adjust kind of its rotation on the hit. I'll show you that in a second. Actually, let's do it wrong by purpose, so just so you can see what's going on. So we'll do vector 3 dot up, and then we input the hit normal. Cool. Quaternions and rotation can be quite difficult. Just know that this is the standard way to do it for now. I don't really have time to go into that. Cool. So let's find our pistol. Let's make sure we have a hit prefab assigned. Maybe we should also make a warning if we don't. We don't have that for the others. We'll just ignore that. Make sure it's remembered. And let's put in a prefab of some sorts. For now, I'll just use the muzzle flash prefab so we can clearly see if this is working or not, and then we'll create one in a sec. So now when we hit stuff, it's definitely not working because it's not instantiating. So that means that the code is not being called. This should be if it's not equal to. Now it should be working. So if we hit up here, we don't instantiate anything, and then here we do. And you can see that the prefab is turned 90 degrees, and that's why we are using this vector3.right instead, to make sure that it's turned correctly. That's kind of how it orients itself. Let's see. And now it's actually using the normal. And of course this looks plenty kinds of stupid. So in order to make this look a little better, let's quickly make a particle system. So let's go under game object, particle system, focus on it in the scene here, and we'll make some sparky looking things. We can maybe put it over here. And first off, we'll set looping. Okay, we'll set the duration to 1 so we can see how this looks every second. And then down here, we'll set the rate to 0, but instead add a burst. You can see what that does, and it will loop and burst once again every 1 second. And the amount of particles, I think 30 is going to be a fine starting point here. I of course want to bring down the lifetime to about maybe 0.5 seconds. I think that's okay. Maybe that's even too long, 0.4. We'll make it go out quite a bit faster. So 10 looks pretty okay. But we want to vary the speed. So let's make that a random between 2 constants. And we'll make that between 2 and 10. That looks much better. And the start lifetime should definitely be brought down here. And also I'll just turn this particle system sideways so that we can see what will happen if we turn on some gravity. So we'll add a gravity modifier. Let's try 1. I kind of like that effect. Then what we can also do is make it change its color over lifetime. And we'll start out by making it fade on the alpha. Fade out like that. Also, we'll make it fade in just very, very quickly. Yeah, like that. And then we can make the color, maybe make it kind of... Actually, I want to add some additive particles instead of these default ones. So let's drag in our additive material. Oops, that doesn't work with that. So let's make another one. We have the particle glow. We could use that one. Let's try it. See how it looks. It's being annoying. So let's drag in the particle glow here. Yeah, I actually like that quite a bit. And then we can change the color in here. So we'll do something orangey. We'll do very orange in the beginning and then fade to white. I think that looks fairly decent. This is not going to be perfect. You should really mess around with this a lot more than I'm doing here. But I just want to get something that is all right at least. Then when it comes to the shape, I want this to emit from basically 1 point. Very small angle or very small radius, I should say. Maybe we could change it to a different shape. I think we're going to do a hemisphere. That kind of looks a lot more like it's emitting from this single point and then just out in a random direction. And I think we can add a bit more gravity. So let's do 1.5. it's starting to look like something, then we can change the size of the particles to be random between two constants, between 0 and 1. And maybe we'll bump down the speed a bit. Again, yeah, that's better. And I think 0 and 0.5 is maybe better. Yeah, it definitely is. Then we can also vary the lifetime to be random between two constants. And now we are starting to get something that looks pretty damn cool. So I'm just going to keep that for now at least, and we'll try and see if that's working. So let's rename this to impact particles or hit particles, whatever you want. And let's drag it under the prefabs. Let's delete it from the scene. Let's select our pistol, drag it under the hit prefab, and let's try. So you can kind of see what that does, and I think it looks really, really awesome actually. However, you will see that it's currently looping, so let's just select it down here and make sure to turn off loop. So let's try this again. Let's actually do that in full screen because I think we have something that we can be pretty proud of now. And yeah, that's indeed working, and I think it looks really, really awesome. Great, and just to make sure that they are facing correctly, not that it really matters if it looks great, but if we just click on the platform here, click on impact particles, and then select the tool, you can see that they are pointing upwards. So that's working like it should. And also inside of our weapon code, it's a good idea for us to delete these after a little while. So what we can do is you can of course make them auto delete in the particle system, but I like to have control over that. So we are simply going to collect them, call these hit particle. And we're going to cast it as a transform. And then we will destroy hit particle dot game object in about a second. Awesome. So now when we play, we should see them disappearing from the hierarchy when they're done playing. And indeed, they do. So now we have tied our shooting mechanics together, and it really gives this awesome feel when you hit something. Next up is some particles when we destroy stuff, and we kind of need to make this game actually into a game because currently it's very much only for testing, so there's plenty of stuff to do. Yeah, that was pretty much it for today's video. That was quite a long one. I hope you enjoyed it, and I'll see you in the next one.